So there's really a lot to talk about ontologies. I'll try to summarize our workflow and how to create the ontologies and load them into the database. Just in a nutshell, I won't go too much into the technical details. I can talk to anyone later on about how to run the loading scripts and how to maintain the ontologies. And one thing to remember is that an ontology is it's an ongoing process. So don't try to create an ontology and think that your work is done, because it's always evolving and changing. Yeah, so to get started, you need to have the ontology in an OBO file format. It's a pretty old file format. I'm not sure if it's the perfect way, but it still works for us. So that's an example. Here's an example from the cassava trait ontology, which is stored at the Plantome repo on GitHub. I won't go too much into detail about the actual OBO format, but there are ways to validate that your format is correct and that it can load into your instance of Breedbase. We have in Breedbase, we have the notion of a variable. So the OBO file has a bunch of terms. Each one has an ID and the name, a definition, and other things like synonyms and relationships. What we call a variable is different from a trait in a sense that a variable is pre-composed. It has in its definition the method and the scale. So we pre-compose the term, we already predefine how the variable is measured. So in this case, if the trait is sprouting, we don't want the end user to use the trait sprouting, we want them to use the variable sprouting proportion. So they're measuring sprouting. The method is by counting the sprouts, and the scale is a ratio. So it's not an actual number, it's going to be a ratio. If you look at the OBO file from Cassava, it has in it IDs for the traits, for the variables, the methods, and the scales. And each one of those also has a different namespace. If you look at the top, at the variable, there's a term, then ID, then the name, and then there's a row where it says namespace. So you can see the namespace is different for the variable. The methods have a Cassava method namespace, and the scales have a Cassava scale namespace. And the reason for that is because in Breedbase, we don't load the methods and the scales. And this is for many reasons. The major one is because most of those crop ontologies are stored at cropontology.org, and they for years used method scales and traits, and each one of them got a different ID. But for Breedbase, we said we can reuse the methods and the scales. We don't need to store them. It just multiplies the number of terms in the ontology. So we introduced the notion of a variable that has in it built in a method and a scale, and then we don't really need to store in the database the Cassava methods and the Cassava scales. And I'll go into that a little bit more into details later on when I talk about post-composing, which we also allow in Breedbase. The tool that we use for editing the ontology is called Protege. You can go to this URL. They have a nice wiki with documentation. It's really an overkill in most cases, but it's the only tool that can parse correctly an OBO file. There's an old program called OboEdit, but it's no longer maintained and it crashes, so don't use it. For most really simple and small ontologies without too many relationships, it can be edited manually, but it's always a good idea, even if you edit your ontology manually, to try to open it in Protege and see if you have any errors, because the database is really quirky, and if you have tiny errors, it will crash completely and you won't know why. So one way to use it is just to validate your file. Later on, when your file gets bigger and bigger, it's much better to edit it in Protege and not manually. Here's an example for a screenshot from Protege. You can see a lot of stuff is going on here. It has the same term, sprouting proportion, and you can see all the annotations and the relationships here. So I think it's worth investing in learning how to use Protege. We have this little Google Doc we wrote for the Protege workflow. This is what works for us. I can share the link with you later on for anyone who's interested. And then this is what the ontology would look like when it's stored this is an example from Cassava base. This is our ontology browser. And you can see here under the trait sprouting, you see only the variable. You don't see here the method and the scale because we did not load them. We just ignore those namespaces. Another way to access the ontology terms is with the trait search. You go to the search menu and go to trait, and you can search by name. Usually we refer the breeders or the users to the trait search and not to the ontology browser. The ontology browser is more technical, and the breeders don't really care about the relationships between traits, variables, and so on. They just want to see the terms that they can save in lists for phenotyping their data. So this is where you would go to create your list of terms of traits, or what we call variables. And each ontology term has this little page of its own where you can see all the definitions and synonyms and links to other databases if it's mapped to a different ontology. You can see here under CV term details, there's trait properties, the format, and detailed description how this trait is measured. The trait format is important for the Fieldbook app. I'll show you later how to load those formats. And then you have this little overview from the ontology browser. You can see the hierarchy. Many people focus a lot on the hierarchy and what is biologically correct or programmatically correct, and it doesn't really matter. As long as you don't have a cycle in your ontology, it's fine. So as long as you don't say sprouting proportion is a variable of sprouting and the parent term also has a child-parent relationship to its own child, as long as you don't create cycles, it's fine. And really, those relationships can be edited as you go. So usually we tell new Breedbase users, just give us a list of the traits you want to measure now. Don't worry about the hierarchy and the ontology tree and the relationships. And then you can just create a flat list of your 10, 20, 50 traits that you're measuring. And later on, you can move them around and create that nice looking tree with the correct categories. But to get started, it doesn't really matter. You just want to have the end product, the pre-composed term with a very good definition. You want to have the method and the scale in the term definition, and this is to avoid more problems down the line. If you don't define exactly how the trait is measured, then you can have multiple phenotyping trials, and each one can interpret the trait in a slightly different way. If they might measure it slightly differently, or they might store it with a different unit. So you want to be very specific on how you want the trait to be measured. And in this example, there is only one variable to the term sprouting, but you can add as many variables as you want. If you measure sprouting in 5 different ways, or you have different breeding programs, and one wants to measure a proportion and the other one wants to count it, and somebody else wants to measure it with a color or something, you can add more variables. Each variable is going to have a different method and scale and a name and the unique ID, and that is perfectly fine. If you have something that can be transformed, if somebody is measuring height in centimeters and somebody else is measuring in millimeters, then you don't want to add multiple variables because those can be easily transformed. So it's this balance between not inflating the ontology too much, but giving the users a way to store their phenotypes meaningful, correct way. So I mentioned at the beginning crop ontology. So this project started, I don't know how many years ago, probably 10, maybe more. And they have ontologies for dozens of crops. We're working in close relationship with them to have the same version of the ontology on the Plantium, GitHub, in Breedbase, and in cropontology.org. We haven't been very successful in doing that because the update cycle is not on the same timeline. But we're getting there slowly, at least with the RTB crops. So if you go to crop ontology and download an OBO file for a certain crop, it might not be ready for loading into Breedbase. It might need to have some work done. And all the ontologies on cropontology.org, they have the methods and scales. And if you want to update your ontology, let's say you work on maize and you edit the OBO file and you want to update it in crop ontology, you have to have those methods and scales even if you don't store them in your instance of Breedbase. They still want to have it because they have some users that need to have the method and scale terms. But you can see here, this is the same variable, the sprout proportion of sprouting. And you can see here it's composed of the, here's the trait, here's the method, and here's the scale. And they have these little tags next to them that tells you that these are methods and scales. So for us, it's not very important. It's just for keeping those databases in sync, because we still want to collaborate with them. So this is what I mentioned before. This is really important. Most of our, in the official copy of the ontology, all of the terms need to be pre-composed with the method and scale in the definition. We have working copies of each ontology in the Plantium repo. This is managed by the lab of Pankaj Jaiswal in Oregon. They manage plant ontology and the plant trait ontology. So we want all the working copies of our, for different ontologies, we want to have them in Plantium, so there is one centralized place where we can refer people to download or contribute to a certain ontology. So here is again the cassava trait OBO file. We want to have only one instance of it so we don't have diverged versions. When people want to edit the ontology, because we have multiple curators for cassava, the workflow is one curator would edit the OBO file, create a branch, commit it to GitHub, and then have a pull request. And somebody else needs to review it and then merge the changes into the master copy. It can be pretty tricky to keep track of the history of the OBO file because it's just a plain text file. It's not like a piece of code. So if you open it in a different program, so I don't know, you find something else where you can edit your OBO file, and then the order of the terms switches around, that's going to be a problem because GitHub is going to see it as a deletion and addition, and then it's very hard to keep track of the changes. So we want to keep one master copy and then make many incremental changes, so it's easier to keep to track the history of the ontology. We also have a crop ontology variable request form. So if people want to add a new term, the workflow that crop ontology had was the breeders would add new traits as they go in the field and phenotype their crops, and then they say, oh, I'm missing this trait or that trait, and I need to add a new one. So they would add those traits as they go, and then at the end of the growing season, maybe once a year, they would submit their terms to crop ontology. And then we would end up with an OBO file that's outdated and you get edits from 2, 3, 5 different breeding programs. And then it would take many, many months for a curator to go over it and try to put things together. What we do now is we want our users to request new terms as soon as they need them. And now they have to do that because if they want to upload data into Breedbase, they have to create a list of traits. And they cannot create a list of traits if a certain trait is not in the database. So this form allows them to go here, write the term that they want. They can also request to update an existing variable or to add a synonym to a variable if the term already exists, but they want to have a different name to it for some reason. And then here they can click on submit to GitHub, and this submission form is going to create an issue on the relevant repo. So if they submit a trait to for cassava, the form will create an issue on the cassava trait repo on Plantome's GitHub. So you can see here there are a bunch of issues, and the issues that have next to them the creation request tag, those are issues, those are term requests from the ontology submission form. And I have here an example of a closed issue that somebody submitted, and you can see here the name of the person, where they are from, the name that they want, and they have to submit a definition, unit of measurement, and how they measure it, the method. And then a curator needs to go in and resolve this issue. If they create a new term, they need to create a pull request, and then that gets updated in the ontology. And then the last step is to update the ontology in the database. Every time there's a change, we need to rerun the loading scripts and update the ontology. So before I talk about the loading scripts, I just wanted to mention we also have a post-composing tool. And we use that mostly for terms that would create huge inflation in the ontology. So here's an example from Cassava base. We have here under base trait, on the left side, you can see where it says object. You have here different parts of the root or parts of the leaf. So if we have a term related to root and we want to say, oh, is this an axial root or a distal root? If we were to pre-compose those terms, we were going to duplicate all the root related terms, because for each one you need to add a variable for axial root and a variable for distal root. But probably for, in 99% of the cases, we don't need to distinguish between axial or distal root. The term is just going to be related to root color, size, and so on. So for more complex traits that have more grainy parts in them, we'll let users post-compose using things like small parts of the plant. On the right side, you have different attributes. So in Cassava, they wanted to say, oh, is this a grated boiled root, or a grated dried root, or a grated fried root, or grated raw root? So you can see how easily these terms in the ontology can grow exponentially. So instead of pre-composing everything, we'll let people cherry pick exactly what they measured in their very specific use case. Under object and attribute, you have the traits. These are all the variables from the ontology. And then we have, if you scroll further down, we also have time terms. So in many of the databases, people wanted to say when they measured a certain trait. So we have months, weeks, days, and hours. So if some trait is measured throughout the year, once a week, we don't want to add those time attributes to every single trait. but if you measure it only for your specific small experiment, you can create those traits in the database. Once you create all those different parts of your new traits, you can see it at the bottom on the right side where it says new traits. So I selected here storage root, pulp color, visual rating. This is pre-composed trait. And then it was measured at month 6, and it was measured on the distal root, and the root was mashed, for example. And then you can click on submit, and it will create a new CV term in the database. This is not part of the official ontology. This is only local, internal to the specific database. So this is going to create a new CV term in Cassava base, but nobody else can see it. It's not on GitHub, it's not in crop ontology, it's not official anywhere, but users of Cassava base can reuse this term. Let's say somebody else happens to have the exact same combination, they can reuse it and add this term to their list. If that term happened to already exist, you would see it on the left bottom box where it says existing traits, and then the database won't let you submit that specific term. We do not have any post-composed terms in Cassava base, but here's an example from sweet potato base. And this is what I mean when I say that the new CV term is going to be created in the database. You can see here under composed traits, all the variables that were created by users. So they get their own unique ID. They look exactly like any other ontology term, and they're and you can see the different parts of that term. You can see where it came from. So you took the ID from the trait from sweet potato trait ontology, and the time from the time ontology, and the what else is here? It says here after harvest, so it can tell you exactly when it was measured. If you go to the sweet potato post-composing tool, you can see that it looks different than the post-composing tool in Cassava base, but it's exactly the same concept. You can define which parts or which vocabularies you can see in each database. So in sweet potato, each post-composing tool must have the base ontology, the base trait ontology, but then you can decide which vocabularies you want to use for post-composing. So in sweet potato, we have the time series, and we have these, here we have only three events: after harvest, after planting, before harvest, and we can add more terms to these boxes. As you can see in Cassava base, we have other options, and these are defined in the conf file for each database. So it's a very flexible, very informal way for letting people create more specific terms if they need it, and a good way for us not to multiply the number of terms that we have in the database. Those little vocabularies you just saw here in Cassava, the object, attribute, time, and in sweet potato and in the other databases, we have those in OBO format, again, in the SGN repo under the ontology directory. And you can see we have here plant level, time, units, and other stuff. So we can add more of these OBO files, or these are really lists of vocabulary terms. So the time is just a flat list of time of year, or units is just going to be a flat list of units that you can use for post-composing. Here's an example from plant level. So you can see the format is OBO, but it's very, very simple. It just has ID. It has a prefix. Each one has a prefix of plant level. And then it has a name. This is the name you see in the database, and a simple definition. And every single term, there's no complicated hierarchy. Every term inherits just from the root term of plant level. So this was from the Breedbase side. I just want to quickly go over the tools we have for populating the database. I won't go over exactly how to run these scripts, just in general where they are, where you find them, and what you need to run them. So those scripts exist in, they're part of the Gmod project. So you need to go to that repo in GitHub, and what you want to clone is shadow tools. So this is the repo you need to clone. Sorry. Shadow tools. It has the loading scripts. If you go to GitHub, you clone this repo, and then under you go to the shadow directory, then bin directory, and the first script you need is called gmod load cvterms.pl. And what you need for that script is a valid OBO file, basically. It has tons of options. Now you need to tell it which database you're populating, the name, the prefix for your ontology, and so on. But all of those pieces of information, they all come down to the OBO file. So you have, you created a new OBO file, you validate it in Protege, you make sure the Protege program opens it with no errors. And then the next step is to run this script and populate your shadow schema. After running this script, if it doesn't fail and everything looks good, it will tell you at the end, you need to run now gmod make cvterm path. And this script you run on an ontology that is already in the database. Every time you update the ontology, you want to run it again. The only thing it does is that it enables the search on the Ontology Browser, because ontologies can have very complex relationships, multiple parents, multiple children. cvterm path just lets the Ontology Browser tool and Breedbase look up those terms very quickly without having to traverse the ontology tree up and down hundreds of times for every ontology term. So you go to that script, it has a Perl doc, and it tells you exactly which options you need there. And the last thing that you need, this is not in the Gmod repo. We were talking about adding it to the Gmod repo in GitHub, but it's still on in the SGN repo, Soul Genomics. The script is called load traitprops.pl, and this is important for the display of the of your phenotyping platform on the Fieldbook app. So here you can attach for every single trait. You can attach things like what is the minimum or the maximum. Does the trait have different categories? Let's say you only allow categories like 1, 3, 5, and 7, and so on. You can store default value. You can determine what is the format of the trait, if it's quantitative, qualitative. And after running this, these trait properties allow this type of display. When you go to the Fieldbook app, if your trait has a format of percentage, you will see on the left side, you can select percentage. If you selected categories of 1, 3, and 5, and 7, Fieldbook app is going to display those categories. Yep, so those are the 3 scripts you want to run. And I think that is all I have. Yep.
Super, thank you very much. Are there any questions? There was a lot of stuff. Even my brain is frying.
Sorry. I try not to go too much into technical stuff, but if anyone here is going to load an ontology, I will send you the exact links for all these tools that you need because you need a lot to get started.
Thank you, Nama. That's really helpful. And we will probably be needing to do this in a very coordinated and quick, fast fashion as much as we can, because we do have a lot of ontologies to build up and load. So I'm sure both, I'm sure the BI group would be very happy to have those links provided.
So do we have a lot of this documentation on our internal wiki, or?
Yes, we